மாணவர்களின் சிந்தனைகளை வடிவமைக்க இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் தனித்திறமைகளை மேம்படுத்த SNS இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் போற்றும் SNS இன்ஸ்டிடியூஷன்ஸ் கோவை.
Hi everyone, this is me Vijay Kumar, Assistant Professor, Department of Electrical and Electronics Engineering. Today we are discussing about pneumatic and then hydraulic systems. So first of all, we are going to discuss about any type of modern construction or a manufacturing applications is probably going to incorporate one or all of three different kind of power: electrical, hydraulic or a pneumatic. So while some actuators and lifting devices can be purely electrical using a screw systems, it is a far more likely you will be using some form of fluid power. So this means you have to choice between hydraulic and the pneumatics. So pneumatics provide the fluid power by means of pressurized air or gases. Hydraulic provides fluid power by means of pressurized liquids such as oil or a water. In choosing one of the two, cost efficient materials to be moved and availability of resources and space. So based on things we are selecting one. So the major thing, it will be a strength. So the hydraulic is the best option for a strength because the liquid medium used for the operation has a high mass density and is largely uncompressible. This means that hydraulic can develop much higher levels of a pressure and can use that pressure to transmit the power that will derive your applications. Industrial applications using hydraulic power may command anything from 1000 to 5000 pounds per square inches. So this is the important one. So the base is the power and then hygiene and then all those things. And also powertrain model, we are using a powertrain model, we are using a mechanical power transmission systems. Mechanical power transmission systems, we are using prime mover as a AC motor, DC motor, diesel engine or auto engine. So the power transmission system is given to the machine the linear or a rotational motions. So the continuously variable drive is difficult and also the relative spatial position of the prime mover is fixed, and if the motor is electrical, so it will be have a different kind of frequencies. And also the hydraulic power transmission system, the hydraulic power means the hydro equal to water or a loose and then pipe. So hydraulics, this means water are injecting to the pipe. The hydrodynamic power transmission system, turbo pump and then turbine is going to be used, and power transmission by a kinetic energy of the fluid and still the relative spatial position is fixed, compact units. Hydrostatic power transmission system, positive displacement pumps we are using and then some other things. The hydrostatic versus the hydrodynamic systems, we are making the graph. The hydrostat and then power density, it will be the hydrogen and then hydrostat, it will be have some kind of different characteristics. So generally larger than 300 kilowatts power, hydrodynamic is more favorable, but for soft operations starting or large masses, hydrodynamic is used for a smaller power either. And structure of hydrostatic drives, we are using aggregate, control elements, actuators. Aggregate will be a pump or a motor or a fluid reservoirs and then pressure relief valve and filter and then piping. Control elements will be a valves determining the path, pressure flow rate of the working fluid. Actuator will be a linear or a rotational or a swinging. The typical hydraulic systems, it will be, for example, showing the diagram, the pump, the oil tank, flow control valve, pressure relief valve and then hydraulic cylinder and then differential control valves. So these kind of valves will help to inject the oil to some kind of piston arrangements. It will give some kind of movements. Advantages of hydrostatic systems will be a simple method to create a linear movement and also creation of large forces and then torques, high energy density and continuously variable movements of the actuators. Simple turnaround of the direction of the movement starting possible under full load from the rest. So low delay, small time constant because of a low inertia, simple overload protections and also simple monitoring of a load by measuring pressure. arbitrary positioning of a prime mover and actuators, large power density, and also the robust thing one. Hydraulic fluid types will be a water will be a 3%, mineral oils will be 75%, not inflammable fluids 9%, biologically degradable fluids 13%, and then electroheliogene fluids in developments. And hydraulic systems will be a gas filling screw, tank, membrane, valve disc, and the structure of the hydraulic systems. And also so this is the example of a hydraulic systems. So this will give the more power with the help of low pressure valve. Thank you. I hope you understood the concept. We will see in the next topic in another class. Thank you.